Hey everybody, this is the second video which will address the A1 solar budget game, the greenhouse effect game, except this is going to focus on the third and fourth portions of that game. All right, so third game. Now in the first two games you just had the sun and the earth. In this third game you actually do have the atmosphere. The atmosphere. Now, mind you, this third game is an early Earth, early atmosphere, no human involvement at all. So this is naturally occurring greenhouse gases of carbon dioxide, methane, and water vapor. The thought process being that whether it be through volcanic action, potentially from the burning of biomasses, the conversation about water vapor evaporating, and or from basically precipitation and so forth, and water and rivers and streams and so forth wearing away of rocks, we have the release of the carbon dioxide, the methane, and the water vapor, naturally occurring greenhouse gases. So just like the Earth, that's going to release half of its energy at the end of every day, the atmosphere is going to do the exact same thing as well. And so I'm going to walk you through a couple of days so that you can see what happens, and then we'll address the fourth and final game. So every day, again, like before, we always are going to add 10 energy units from the sun to the Earth. So 2, 4, 6, 8, and 10. All right, so we got 10 here. Now, at the end of each day, the Earth goes through radiant cooling, and it's going to go and release half of its energy. And so we can tell and see that the Earth before radiant cooling is here. The Earth after radiant cooling has been cut in half, so it's 5. And you're going to notice that we're going to go and take the other half of the Earth and put that out into the atmosphere. So I need to take 5 and put that on the atmosphere. 1, 2, 3, 4, 5. So I've got 5 on the Earth, 5 on the atmosphere. I'm going to just do this so that you can see it all. All right. Now, the atmosphere, the atmosphere's got space above it and the Earth below it. And so the atmosphere actually is going to slowly release its infrared heat that it's captured from the Earth. And we're just going to kind of keep this 50-50 rule and just keep splitting it in half. And so based upon our worksheet here, our chart that started to be filled in here, we're going to say out to space is 2. So we're going to take 2 and put it into space. And then this out to space portion here, we'll just acknowledge it. We're not going to do anything with it, but it's gone back out to space. And we're going to ask that the atmosphere take these 3 M&Ms and bring them back to the Earth. So now the Earth took the atmosphere's energy back. And so now we're going to go and take and do a little bit of adding here. We've got the 5 from the Earth after radiant cooling, the 3 from the atmosphere. So 5 plus 3 equals 8. All right. The Earth has 8. Let's go to another day, day 2. So 2, 4, 6, 8, and 10. So now I'm going to do my math, partly in my head, but also on the paper here. If I had 8 on the Earth and I just added 10, that brings us up to 18. And so I should see 18 here, and I do. Bravo. And now the Earth is going to be cooling throughout the day, especially the dark side of the Earth where there's no sunlight. That 18 cut in half will be treated as 9. And so we're going to keep 9 on the Earth, but we're going to put 9 in the atmosphere. So 2, 4, 6, 8, 9. So now we have 9 in the atmosphere and we have 9 on Earth. Again, we're going to play the rule of 50-50 here, and we're going to say that the atmosphere, we're going to chop that in half, and our paper says 5 out to space and 4 back to the Earth. Now, whether I had gone and done 4 out to space or 5 out to space is not necessarily the issue here. You can go and change that going forward for the other days, but there is a little bit of a process that I do recommend, and I'll show it to you on day 3. So I've got 4 in the atmosphere that I'm going to go and dump back to Earth. Now this is, again, naturally occurring greenhouse effect. This is the combination of water vapor, carbon dioxide, and methane trapping thermal infrared heat and sending it back to the Earth. All right, so let's do a little bit of math here. We just went and had 9 on the Earth, and we just added 4. So 9 plus 4 equals 13, and I see it right there at the very end. 9 plus 4 equals 13. All right, let's go to day 3. Now you'll notice here on your paper, the first column on the far left there, it doesn't have tens all the way down, and I want you to type in tens as you see fit based upon how many days you need to get to a point where the temperature stops changing. So I'm going to put 10 down on there, and now I've got 13 on my Earth. So I'm going to do 10 plus 13, which will be 23. So I'm going to add 10 more. 2, 4, 6, 8, 10. So So if I've got 23 there, I need to cut the 23 in half. And I know that's 12 and a half, but unfortunately we can't do half M&Ms. So instead, what we'll do here, actually, I apologize, it would be 11 and a half. We're going to do an 11 and a 12 is what we're going to do. So 23 cut in half is 11 and 12. And so I'm going to go and put the 11 in this column, and here's why. I'm going to put the even number 12 into this column on the out to the atmosphere. And the reason for that, I know that whatever I put in the atmosphere, I have to go and divide in half. So if I put 12 there, 2, 4, 6, 8, 10, and 12, if I put 12 there, dividing the atmosphere in half will be easier because it's just, to me, easier to go and divide even numbers. And so if I've got 12 in the atmosphere, 12 mentioned there, out to space, well, that's going to be 6. Back to the Earth, that's going to be 6. And so now I can do this. 11 plus 6 equals, ladies and gentlemen, 17. And so I do 6 out to space. 1, 2, 3, 4, 5, 6. And I'm going to take these remaining 6, I'm going to bring them over to the Earth here. And so now I should have 17 on the Earth. And I go ahead and count that and tell you that I have 17 on Earth. And so you're going to keep doing this until you get to a point where the temperature, which is this far right column here, you're going to keep going until the temperature stays the same. Because the amount of energy coming in equals the amount of energy going out, and the Earth temperature has become stabilized and balanced. Equilibrium has been reached. Now, the fourth and final game, and it takes a moment here, I do apologize for my screen to load. The fourth and final game is a little bit trickier, except now we have humans involved. We have humans involved, and humans are burning fossil fuels. Now, the reason that we need to go and do this fourth game is because I want you to understand that the Earth, with the naturally occurring greenhouse effect, was automatically going to be warmer than the earlier two Earths in Game 1 and Game 2. So we knew that that was going to make the Earth warmer, but that warmth, the temperature that the Earth got to, made it livable, allowed for life to evolve on it, allowed life to exist on it, instead of it being a frozen ice ball. However, with humans burning fossil fuels, I want to acknowledge the fact that humans are releasing ancient sunlight. Whether it's oil, coal, natural gas, we're releasing ancient sunlight. We're also releasing a combination of carbon dioxide, methane, water vapor, nitrous oxide. We're releasing quite a lot of bit here. I know it seems to be a little bit overly generalized in this game, but I'm going to ask that we acknowledge that fossil fuel burning by adding a 1 to the end of each day. And so we're going to add a 1 to the end of each day to represent what it is that humans are adding to this system. So check it out. On the screen there, you'll notice here it starts off with 10 each day again. And so we've got 10 sent to the Earth from the sun, Earth before radiant cooling, 10. Earth after radiant cooling, 5. 5 went out to the atmosphere, so there's your 2 5s. And now the atmosphere is going to go and cut itself in half and be 2 and 3, just like it was in Game 3. So we do the 5 plus 3, and here's the fossil fuel part, plus 1. And so now we can see that we jump up to 9 at the end of day 1. Now, it was 8 at the end of day 1 in Game 3, but now we're up to 9. Let's try the next day. 9 plus 10, 19. 19 cut in half, 9 and 10. Remember, I like to put the even numbers in the atmosphere because the atmosphere gets divided again. Cut the atmosphere in half, 5 and 5. So now we do 9 plus 5 plus 1, 15. So, my goodness, at the end of day 2, we were up to 13. But at the end of day 2, with the fourth game, fossil fuels, we are up to 15. And so we're going to keep going with this until, again, we find a point when the temperature stabilizes. We find a point when the temperature stabilizes. And here's this kind of like thought, a little bit further extended thought, if you will. Based upon this game, we're only adding a 1 every day to the end of the day to represent all the fossil fuels being used. I would ask as a class, has the rate to which we've burned and utilized fossil fuels been consistent this whole time? Or has it gotten higher and higher and increased as we've gone and produced more and utilized more? So in many ways, the 1 is not an accurate representation. We probably should turn it into a 1.5, and then eventually maybe into a 2, and then maybe into a 3 or a 4. But keep the game going. Find the point when the temperature stops increasing, and that is the end of the game. All right, you guys, thank you so much.